Hi everyone, welcome to Arunachala CC. This is Shipadarathi from CC Department, Arunachala College of Engineering for Women. In this video, I am going to deliver a lecture on Stack ADT from the subject CS8391-Data Structures. These are the contents we are going to see about Stack ADT, that is introduction and what are the operations performed on Stack ADT and the implementation detail. Stack is one of the most useful concepts in computer science, which is used for storing the information. Now let's see the definition of stack. Already we know stack is a linear data structure which is used to storing information in a manner LIFO. The stack follows last in first out policy because here the insertion and deletion operations can be performed at only one end called top of the stack. Here the top pointer will always point to the top of the stack, that is the last element inserted in the stack. For an empty stack, the top pointer will be pointing to the value -1. So, once the stack is ready, what are the operations we can perform on stack ADT? There are two basic possible operations on the stack, or first one push operation, second one pop operation. For push operation, it is the process of inserting a new element into the top of the stack. Next, pop operation, it is the process of deleting an element from the top of the stack. When we use two basic operations, that is push and pop, two situations may be arise. First is stack underflow condition, second is stack overflow condition. The stack overflow condition means it is the situation when the stack is full and we want to insert a new element into the stack. Stack underflow condition means it is the situation when the stack is empty and we want to delete one element from the stack. For every push operation, we need to check the condition stack overflow, and for every pop operation, we need to check the condition stack underflow. Next, we go for the implementation part. We can implement the stack using arrays or linked list. Array means the static implementation and linked list means the dynamic implementation. Let's first see the array-based implementation. In array-based implementation, each stack is associated with a top pointer. Now, let's see the routine to push an element onto your stack. It is the process of inserting a new element at the top of the stack. It takes two parameters as input, that is x and s. That is the element x to be inserted at the top of the stack s. Before inserting an element, first we check for stack overflow condition. That is, the stack is full or not. If top of the stack equal to array size -1, that means the stack is full. If the stack is already full, here the insertion is not possible. But if the stack is not full, we insert a new element by using two steps. First, we increment the top pointer by 1 and then insert the new element x at top of the stack. That's all the push operation. Now we go for the pop operation. It is the process of deleting the top element from the stack. It takes only one parameter x, that is to be deleted from top of the stack. before deleting the top element from stack, we check for empty stack. If top of the stack equal to -1, then we return the condition stack underflow. That means the stack is empty. The stack is empty. Here the deletion is not possible. But if the stack is not empty, then delete the top element from the stack and then decrement the top pointer by 1. That's all the pop operation. Next we see the routine to return the top element from the stack. Normally the pop routine is used to delete the top element. If the user needs to know the last element inserted into the stack, then the user can return the top element. To do this, first check for empty stack. If the stack is empty, then there is no element in the stack. So here we return nothing. Otherwise, return the element which is pointed by the top pointer in the stack. That's all the array implementation. Next we move on the linked list implementation. Here the stack is implemented by using simply linked list concept. First, the push operation is performed by inserting an element at the front of the list, and pop operation is performed by deleting an element at the front of the list, and the top operation is used to return an element at the front of the list. Next, the node declaration, because linked list consists of series of nodes. Here one node is defined by using the structure concept. One node consists of two parts. First one, data part, it returns the data type integer. Next one, the next pointer that returns the address of next node. Now let's see the routine to push an element into the stack. It is the process of inserting a new element at the top of stack. With linked list implementation, a new element is always inserted at the front of the list, that is S of next. It takes two parameters X and S, that is the element X to be inserted at top of the stack S. Here first we allocate memory for the new node by using malloc function. If the memory is enough to insert, then we insert new element by using 3 steps. First, we insert the element in the data field of the new node. Then update the next field of the new node with the address of head node, that is S of next. Finally, we store the address of new node into next field of head node, that is S of next. That's all the push operation. Next, routine to pop an element from the stack. It is the process of deleting the top element from the stack. With linked list implementation, the element at the front of the list, that is S of next node, is always deleted. It takes only one parameter X, that is the element to be deleted from the front of the list. Before deleting an element, we check for empty stack. If the stack is empty, then the deletion is not possible. Otherwise, make the front element in the list as temp cell. Then update the next field of header. And finally, using free function, deallocate the memory allocated for temp cell, because that node is deleted. So the pop operation. Then last, the routine to return top element from the stack. To do this, first check for empty stack. If the stack is empty, then there is no element in the stack. So here we return nothing. Otherwise, We return the element present in the S of next node, that is head of next node of data path in the list. That's all the implementation of stack data structure. Thank you all for watching this video.